Okay, so this is problem 1.46. So 46, it gives us a picture of two vectors, vector A and vector B, on an xy coordinate plane. And the problem says for the two vectors in this figure, find the magnitude and direction of A, the vector product of A cross B, and then it wants us to find the vector product of B cross A. So in order to do this, we first want to find the x and y components of the vectors. So this we can find, so for vector A, to find the x component of the vector, we would take the distance, which it gave us, 2.8, times the cosine of this angle here, so 60 degrees. And for the y component of vector A, we would do the same thing, 2.8, but instead of taking the cosine, because cosine, remember, is adjacent over hypotenuse, so that's finding this length, this adjacent x length. And so we take the sine because that's opposite over hypotenuse, which is this y length. So we'll do sine of 60. And when you calculate that out, you should get 1.4 for the x component and 2.424 for the y component. And now for vector B, you want to do the same thing. So for the x component of this, we want to actually use this angle here, which we know that this is 90 degrees. So if this is 60, this would be 30. And so the x component is, okay, ooh, forgive me. No, it's the same thing, because we're looking at this triangle here. So we're finding this x length, and it's probably something like that. So we would also take 1.9, so this vector magnitude, so the cosine of 60, and the y component would also be 1.9 times the sine of 60. So that would be so 0.95 for the b component, and negative 1.65 for the y component. Okay, so now we know the components of the vectors, so we can write it, you can see this, we can write vector A as 1.4, 2.424, and 0. And vector B we can write as 0.95, negative 1.65, and 0 as well. So now we are going to find the cross product. So I'm going to erase this. Okay, so for problem part A, we're doing A, vector A cross B. So in order to do this, you will take, so vector A cross B would equal 2, so you take the y component of vector A cross the z component of vector B. So 2.424 times 0 minus the z component of vector A times the y component of vector B. So that would be 0 times negative 1.65. And that would be your I hat. Then you will add, sorry, this is all in parentheses. And then you will do the z component of vector A times the x component of vector B minus the, where is I? Z component of vector A times the x component of vector B, and then you will take the x component of vector A times the z component of vector B. And that's your j hat. And then you'll add your k hat. So your k hat, this time you're probably not going to get a 0. You will multiply the x component of vector A multiplied by the y component of vector B, and you will subtract the x component of vector B times the y component of vector A. So that is how you do the cross product, and we end up getting 0 for the I hat, 0 for the j hat, and when we multiply this out, we get, let's see, where is it? We get the product to be negative 4.63, rounding to the nearest hundredth for our k hat. It also says to find the direction. So in order to find the direction, we'll take, so that will be our theta. We'll take this inverse sine of our k hat over the vector magnitude of each of those multiplied. So 1.9 times 2.8. And that gives us negative 60.4 degrees. So that is the cross product of the new vector, which is this vector, we can call it vector C, is negative 4.63 k hat, and the angle for this vector is negative 60.4. And now we need to do the opposite. So let me erase this again. So we still have the same vectors. But this time we are doing B vector cross A. So this varies slightly because we'll start with vector B. So for the x component of this vector, we will do, what is it? So negative 1.65 multiplied by the z component minus the y component, 2.424 times the z component of vector b for our I hat. Then we'll take the z component of vector b times the y component of vector a. Oh, forgive me. Times the x component of vector a minus the z component of vector a times the x component of vector b. And that would be your j hat. There's their hats. And then for our k, we will take the x component of vector b times the y component of vector a minus the x component of vector a times the y component of vector b. Negative 1.65. And since this is negative, you'll end up adding these two, which means we'll get 0 I hat, 0 j hat, and we'll get a positive 4.601 for our k hat. And yeah. And to find the magnitude, you just square it and square root it. So the theta, we need to find our direction for this one. So this would be the inverse sine of this positive 4.61 divided by the 1.9 times 2.8. And we will get a positive 60.4 degrees. And that is problem 46. Thank you for watching.